So, and your test may or may not be in the same order, and I know you don't have your test back, and I'm doing that on purpose. The report of a sample survey of this many adults, what does the phrase 95% confidence mean? So this is saying where I used to say, okay, 95% confident means asterisk refer to. It basically means confidence level. So interpreting the confidence level correctly, do I ever take a percent and directly apply it to my two numbers that I found just from a sample? No. This one is terribly wrong where it says 9% to 15% will spend 95% of what they spent last year. That's completely wrong. This one, again, applies the percent to the numbers in the sample. So we're left with only two options. Both of them say the method used to get the interval. So that's probably better. This one says we can be 95% confident that it always gives the right answer. I'm not even sure what that one's really trying to say. And this is vague. The method used to get the interval that we found here, when used over and over, produces intervals which include the true population proportion about 95% of the time. That is pretty much word for word interpreting what confidence level is. A study was conducted by calling landline telephones, and those conducting the survey were concerned about the possibility of undercoverage. This problem really didn't even have to tell you that part, but it did. So we do a survey, and we are concerned about undercoverage, which means we are continually leaving out a certain group of people who are similar. So which is the best way for us to correct this source of bias? If I use a lower confidence level, is that going to help anything? If I use a higher confidence level, does that usually make things better? Yes. If we're still dealing with a biased group, does a higher confidence level help? Does taking a bigger biased sample help? Does using a T interval instead of a Z interval, I'm not even sure why they would do that. So we cannot fix the bias here. Continuing to use this biased group is still going to get biased results. So we would have to start over and do a better sampling method. We said margin of error only accounts for variation by chance, not anything with bias. All right, which of the following has the highest probability? A lot of people were probably very confused by this at first, but it becomes I could imagine people still not being 100% sure about this one. People did a lot better on this one than I thought they were going to. But you should be able to narrow it down really quick. So if I have a critical value of greater than 3, where is 3 on that graph? Versus this. Should I have any options about which one of those is bigger? So even if you have no idea, you should be taking 50-50 guess here. That part is very straightforward. Now, here I'm doing Z versus T, and this is the part that I think is tricky. If I am dealing with, let's just think backwards here, and I think y'all thought about it a different way, and that's fine too. What do I know about this part of a graph with a T versus a Z? So there is more area here in a T than a Z. So I am just leaving out this little section. So when it is Z, do I leave out more, or when it is T, do I leave out more? Which means that is going to be the better one. And I would imagine that people went a different route because I did not see much writing with people who got this correct. And thinking about this differently is fine. But that's one way to explain how you can do this. Questions on this? I think that was the trickiest one, and I don't think that was the most missed problem. A nationwide poll. Okay, so this one ends up saying, how would the margin of error of a 90% confidence interval compare to a 95%? Margin of error for 99 is going to be what versus margin of error for 95? Smaller, same, can't tell. You don't even have to think at all. Because higher confidence requires larger margin of error. That one I didn't even give you two options that were larger. I think a lot of people missed this one. I give you 4 numbers, and you're making a confidence interval for it. You need to be able to look at a problem like this to help you for the AP exam. I'm immediately going to look at this and see all of those are the same. So why look at it? All of this up here is the same. So why look at it? So now I'm down to just looking at 2 things. So what should go here in your equation? Well, how many were there? So now I'm just down to these 2. So now I have to just decide what my what was. So I have to figure out if it's Z or T. What does it not give me? It does not give me sigma, which means I'd have to use, and you could even look to see if I plug those in that this is S. So I am using a T with 95% and degrees of freedom of 95%. Degrees of freedom of 3 is 3.182. So it's that answer. A survey is to be taken, estimate the proportion. So I'm solving for a sample size. And I'm dealing with proportion. What is my equation? What goes here? Margin of error equals times alright, so margin of error divided by Z. I'm going to go ahead and square both sides at the same time. I'm going to multiply by n over here and then divide by that over there. So I end up with so in this one, it ends up being P hat because we don't know P because that wouldn't make any sense. So I don't know P hat because it didn't give it to me anywhere. So I use what? What is margin of error? Divided by, and then so I need a Z for 96%. 96% Z, 2.054. Is that right? And you end up getting point something. This is how I told you it's going to be on an AP exam. Which is the smallest one that actually guarantees this? So, because is this at least that many? No. So what is the first one that n is bigger is at least that big? So that is your answer. I think a lot of people mess themselves up on this one. In constructing a confidence interval based on a large sample size to estimate the mean of a population with a known standard deviation, that means I would be using this equation. of this equation is dealing with width? What part of this equation is not dealing anything with the width? So we're only looking at this portion right here. This is just location. This has nothing to do with width. Does population standard deviation change the width? Yes, it's over here. Does confidence level? Yes, it changes this. Sample size is here. Is sample standard deviation used in that equation? So which two do not affect the width? The sample mean and sample standard deviation. Suppose the population of the scores of all high school seniors took the SAT maths. Okay. I'm dealing with this, and it tells me this and n. Well, this is my what? What is 512? My x bar. Well, but I'm trying to figure out confidence level, so I probably don't even need that. So 28.07 is the what of my equation? Words. All right, so what is margin of error equal to? Z or T, and I got sigma, so it's going to be Z.
Z times sigma of the square root thing.
All right, so what was my sigma? What is my n? What is square root of 100?
10.
What is 100 divided by 10?
10.
So if I divide these by 10, so looking at this, 2.807 is when I'm dealing with a 99.5% confidence. So it just asks for what is the confidence level that goes with that one, which means that's all that's left. This one was literally just read the t-table. If we're dealing with 96%, I give you this, which means you need what instead? Which is, so you're just seeing where these intersect, which would be here. I didn't look to see if anybody missed that problem specifically. Hopefully they didn't. Tanya wants to estimate what proportion of the seniors in her high school plan to attend prom. I know that I actually might have asked this question when we read this problem in the homework. This is my what? This is my, and finds that 36 of them do plan to go to prom, so that would be my X, which is my number of successes. And all I asked is, why did I give you 750? Is that my lowercase n?
No.
Is that the number of successes?
No.
To show that the number of successes is large enough?
No.
Does that have anything to do with central limit theorem? Does that, is this correct? Because that's not capital N to check my lowercase n versus.